Hi, students. This is another problem type that appeared on week one of the 2020 Math Olympiad test that you took recently. This is not the exact problem because I'm not allowed to put the exact problems up, but this will be one that is kind of like it. And what it asks is there's this number, and you have to figure out whether it's divisible by 110. And to make matters worse is they don't give you all the digits. They put these A's and B's in the number. And so you have to figure out what A and B is and then figure out that it's divisible by 110. So let's just try to see how to break this one down. This is a very tricky problem that, but if you can, I think I can explain it to you so that you can solve problems like this on future math Olympiads. So let's get to it.
Okay, the second problem, divisibility. These are divisibility by 11 problems, and you're going to see these in a number of ways. One of them is, and so this happened on the last Math Olympiad, a problem kind of like this, but this is pretty different from the one you exactly saw on the test. There are a number of problems like this that I've seen back all the way to the 2017 Math Olympiad problems. So I think it's worth looking at because it could recur. You might see it again. So the key thing here is the number is divisible by 11 if and only if the sum of the odd digits minus the sum of the even digits is either 0 or a multiple of 11. And notice, so what are multiples of 11? 11, 22, 11, 22, 33, etc. But remember that also negative 11, negative 22, negative 33 are also multiples of 11. And I don't think that's going to come up on the test, but it might. So I just point that out. Okay. So an example, the number 9,083,965 is divisible 11 because the odd digits, if you add them all together, and then you subtract off the even digits. So if I say, 9 plus 8 plus 9 plus 5, and I subtract off the even digits, I get 22, right? 9 plus 8 plus 9 is 26 plus 5 is 31 minus 9 is 22. And 22 is a multiple of 11. So that number is divisible by 11. Similarly, 121, which we know 11 times 11, 121 is divisible by 11 simply because if I take the odd digits, every other digit, and I add them together, and then I subtract off the even digit, I get 1 plus 1 is 2 minus 2 equals 0, right? So the sum of the odd digits minus the sum of the even digits either has to be a multiple of 11 or 0. So that's my example. Now, the sample problem is a little bit more involved, and this is typically how you will see this problem. And this is a pretty involved question, but I think we can get through it. So the number represented by 1A860A2B is divisible by 110. What is the product of A and B? Now notice there are a lot of tricky things in this problem and some notation that you have to understand to get it right. So when they talk about a number like this, what they're saying, these are digits, but you don't know what they are. So you got to figure out what is A. Is A equal, 1, 2, 3? It's anywhere from 0 to 9. And same with B. B is equal to 0, 1, 2. Somewhere between 0 and 9. And we don't know what it is, but we have to solve it. And we have all the clues that we need to solve this problem. So let's walk through it slowly and see if we can, what they call, unpack this problem. I'm going to make a little copy of this just because we might need it as I scroll down. All right. Now notice the number of places to trip up. And I'll kind of point those out as we go along. Okay, so let's start solving this problem. Well, if this number is divisible by 110, what do we know what is true? This is kind of key. Well, if a number is divisible by 110, it's also divisible by the things that make up. If a number is divisible by 110, it must also be divisible by the prime factors. Now I think you've probably learned to make prime factor trees factor trees inside in your math class, but if you haven't, let me know and I can do a video on that. Okay. So this number we know, again, 1A860A2B is divisible by 110. So we know it has to be divisible by 10 and divisible by 11. Well, what is the 10 telling us? There's a clue. It's going to tell us something about A or B. And I'd like you to pause the video and think about it. And if you know the answer, just kind of say it out loud and let the video keep going. Well, the key is because the number is divisible by 10, it must end in 0. Right? So we know that the B must be 0. So B must be 0. Well, so this problem becomes really easy. If we know B must be 0, we know that the product of A and B, product means multiply. So A times B must be 0. So this becomes a really easy problem. So I'm going to change the problem. And I'm going to say the sum. I'm going to make this be a sum. That means we need to know what A plus B is. So now we still have to keep going and get A. Okay, so we know B must be 0. So now we know that the number is 1A860A20. Okay? Okay, well, let's keep going with the problem. What's the other piece? We know it's divisible by 11. So now let's look at every other digit. We know that 1 plus 8 plus 0 plus 2 minus A minus 6 minus A minus 0 equals 0 or a multiple of 11. So let's keep going. 1 plus 8 plus 0 plus 2 minus A, you can just say A minus 6 minus A minus 0 equals, 0, 11, 22, negative 11, negative 22. We're not sure yet what it has to equal, but we'll do some analysis in a little bit. So let's see. So 9 plus 2, this is 11, minus A, minus 6, minus A equals one of these things. Well, we can reorder these things a little bit. So we can say, well, 11 minus 6 minus A equals 0. So this is 5. So 5 minus some number has to equal 0 or negative 11 or negative 22 or 11. Well, we know that 5 minus a number can't be more than 5. So 22 is out and 11 is out. So all we have is 0, negative 11, or negative 22. Well, 5 minus a number equals 0. Well, it can't be 0 because there's no number that will give you 0. Like if I chose 5 minus 0, that equals 5. Said 5 minus 1, that equals 3. For those of you who know algebra, this is kind of a little bit easier, but I'm just kind of doing it without algebra. So 5 minus 2 equals 1, and then 5 minus 3 equals negative 1. So So there's no way to make 0 by putting a number from 0 to 9 in for a. So it can't be 0. So let's try, see if I can get to a negative 11. So, well, 5 minus 4 equals, well, that's negative 3. 5 minus 5 equals negative 5. All right, 5 minus, let's just jump to 7. 5 minus 7 equals negative 9. And then, well, 5 minus 8 equals negative 11. So 8 works. Another way to do this, if you're trying to get to negative 11, and you know algebra, this is the algebra way. I'm not saying anyone needs to know algebra, but if you said 5 minus 2a equals negative 11, I could add 2a to both sides, and I get 5 equals negative 11 plus 2a, and then I could add 11 to both sides, and then I get 16 equals 2a. So if 2 times the number is 16, then a also equals 8. If you know algebra, then that's cool, but otherwise, this is the way that you can do it this way too. So I know that a must be 8, so that my number is, if a equals 8 and b equals 0, then my number is 1, 8, 8, 6, 0, 8, 2, 0. So that's my number, but let's go back and look at the problem. And the problem says, what is the sum of a and b? So make sure we always looking for what they're asking, because the answer isn't 18,860,820, because they weren't asking for the number. They were saying, what does a plus b equal? So 8 plus 0 equals 8. So our answer to this problem, and put it in pink, our answer to the problem is 8. Very involved. This is a pretty involved question, but if you've made it through there, this is one of the harder problems for sure that you're going to see on the test. Involved a lot of little tricks. All right, we'll see you in Math Olympiad.